Hello everyone. Today we are going to discuss about significant figures. Here you see about significant figures we will discuss few important things. Master the math, significant figures. See here, these are significant figures. Understanding, precision, accuracy and the essential rules of measurement in scientific practice. What are significant figures? The definition is that significant figures or significant figs are the digits in a number that carry meaningful information about its measurement, precision, and resolution. Why they matter? Communicate measurement precision, prevent overstating instrument accuracy, and ensure scientific integrity. These are the basic factors why they matter. A ruler marked in millimeters provides greater precision than one marked only in centimeters. Significant figures help us express that difference accurately. The golden rules for identifying significant figures. Understanding which digits count is essential for accurate scientific reporting. Master these four fundamental rules. Rule number 1. All non-zero numbers. Every non-zero digit is always significant. Suppose 438, therefore 3 significant. These are the rules. Number 1 rules is all non-zero numbers are significant figures. Every non-zero digit is always significant. 438 has 3 significant figures. Captive zeros. Zeros between non-zero digits are always significant. Zeros between captive zeros between non-zero digits. You see 505 has 3 significant figures because this zero is between two non-zero digits. This has 3 significant figures. Leading zeros. Leading zeros are never significant. They are just placeholders. Suppose 0.002 has 1 significant figure. Leading zeros are never significant. These are leading zeros. So these are not significant figures. Trailing zeros. Trailing zeros are significant only if a decimal point is present. 1.2, 120.0 has 4 significant figures. That is 120 has 4 significant figures. 120 has 2 significant figures, right? In this way we can find the various significant figures. Again you see what are the golden rules for identifying significant figures. Number 1, all non-zero numbers are always significant. 48, it is always significant. Captive zeros. Zeros between non-zero digits are always significant. 505 has 3 significant figures. Leading zeros. Leading zeros are never significant. They are just placeholders. 0.002 has 1 significant figures. Trailing zeros. Trailing zeros are significant only if a decimal point is present. 120.0 has 4 significant figures. In this way you can find the rules of significant figures. Calculations for addition and subtraction. You see, your final result should have the same number of decimal places as the measurement with the fewest decimal places, right? Focus on decimal places, not total significant figures for addition and subtraction operation. For example, 25.1, 1 decimal point place. 2.03, 2 decimal places. Calculator, after calculation we get it 27.13. The correct answer is 27.1 limited to 1 decimal places. So you should take one decimal places, right? So this is our answers for addition and subtraction both, right? So what we are getting that 27.13, therefore you have to limit it to 1 decimal point, that is 27.1 to 1. The 27.1 is the correct answer. The next one is calculations, multiplication and division. The rule: the final results would have the same number of total significant figures as the numbers with fewest total significant figures. Fewest or least. Count total significant figures, not decimal places, for multiplication and division operation. Suppose there is 5.02, three significant figures, right? Into 0.10, two significant figures. So if you multiply, you are getting 0.502. So what is the list? Two significant figures. Therefore, the correct answer will be 0.50 must show two significant figures. So it should be the fewest or least total significant figures. Least total significant figures for multiplication and division. Quick reference guide. Addition and subtraction. Match decimal places. 12.11 plus 13.0, 30.1. Match the decimal places. Right? In this way we get the result. This one is multiplication or division. Total match total significant figures. Right? And identify significant figures. Apply the four golden rules. Example 0.04450 has three significant figures. So first of all you have to find what are the different significant figures. After that we can find the various important things, right? So in this way you can find all the different rules. And the next one what you see is this one, common pitfalls to avoid. Confusing decimal places with total significant figures. Remember, addition and subtraction uses decimal places. Remember this, addition and subtraction uses decimal places, while multiplication division uses total significant figures. Know which rule applies to your operation. You have to remember that addition and subtraction it uses decimal places, that is lowest decimal places. And for multiplication division you have to use the total significant figures, and you have to take the least significant figures for multiplication and division. Rounding to early. Keep all digits in your calculator until the very final step. Premature rounding introduces cumulative errors that compromise accuracy. Forgetting about exact numbers. Definition like 12 inches equal to 1 foot, and counted quantities 5 test tubes have infinite significant figures, and never limit your calculation precision. Best practices for success. Number 1. Keep full precision during calculation. Use all digits your calculator provides throughout multi-step problems. Number 2. Round only at the final step. Apply significant figure rules to your final answer to avoid rounding errors. Show your work. Document your reasoning and which rule you applied for partial credit. Double check your answer. Verify that your result makes physical sense and has appropriate precision. Real world application. Why scientists care about significant figures? Significant figures ensure that measurements reflect the true capabilities of our instruments and methods. Reporting 3.14159 from a basic ruler would be scientifically dishonest. It implies precision that doesn't exist. In research, medicine, and engineering, proper significant figure usage prevent false claims of accuracy, ensures reproducibility of experiments, maintains scientific credibility, and supports quality control standards. Key takeaways. Master the four rules: non-zero digits, captive zeros, leading zeros, and trading zeros with decimals only. Know your operation. Decimal places for plus and minus, and total significant figures for multiplication and division. Round strategically. Keep full precision until the end. Then apply significant figure rules to final answers. With practice, applying significant figures becomes second nature. These rules protect the integrity of our scientific work and ensure your measurements communicate exactly what your instruments can truly measure. Thank you for thank you everybody for watching this video.